All right, here we are on Unit 2, just kidding, Unit 8, Day 2. I'm on page 5. We're going to be working with doing a little bit more complex stuff with the trig functions, and I'm going to be using the yellow sheet. This first one up here, we want to get common denominators. And for a brief moment, I want to just take it over here and just say, this is like saying x minus 1. Okay, even though you have trig functions like this, where 1 is plus and 1 is minus, they are different in the denominators. So like this, we want to multiply by whatever it's missing on over here, and x plus 1 over here. You're doing that with the trig functions. And the nice thing about this is when you do it, it's the same thing, 1 plus 1 minus. On the bottom, we just get x squared minus 1. So it's that perfect squares on either one. So when we do this on example 1 here, on the right, I'm missing secant x plus 1 on top and bottom, x plus 1. And on this one, I'm missing secant x minus 1. Alright, so the nice thing about this, so on the top, I have 1 times those. So it's just secant x minus 1. The bottom, when you're multiplying by the same thing, 1 plus and 1 minus, it becomes secant squared or whatever squared, then minus that times that. So 1 times 1 is your 1. Alright, on this one I have secant x plus 1 over secant squared x minus 1. Alright, so common denominators, make sure you distribute this negative to both. So it's secant x minus 1 minus secant x minus 1. So it's like keeping these in parentheses and distributing the negative 1. Alright, so secant x cancels with subtracting secant x. We have negative 2 on top. I have secant squared x minus 1. So I'm going to my yellow sheet. I have secant squared x minus 1, so I want to bring this 1 over, so it's equal to, I can replace that. So I can replace that with tangent, so the top stays the same. Tangent squared x. And so when you do this, whatever number you have on top is like saying negative 2 times 1 over tangent squared x. And the reason this is important is because I can transform. Anytime a trig function is on the bottom, I can transform it into its reciprocal one, which is in one of the boxes here. So ultimately, this becomes negative 2 times cotangent squared x. All right, the next one. You can either try to simplify tangent into sines and cosines, and then 1 over cosine squared, and then sine over cosine. You can absolutely do this. Or I'm just going to take it a different way, so you go ahead and try to do that if you feel like that would be better. Since I did common denominators up top, I'm going to do common denominators again and do some work on this. Okay, so right now this is over 1. So tan theta and tan theta to get common denominators. So when I multiply those, I'm only multiplying that one. I have tangent squared theta over tan. Do not cancel those out because I'm going to get back to what I started with. Minus secant squared theta over tan. Common denominator, so that means I have 1 fraction now. Tan theta. Top is tan squared theta minus secant squared theta. Alright, so what this means is I'm taking that middle one again. So if you need help seeing it, so I have 1 plus tangent squared theta equals secant squared theta. Okay, if I want tangent squared theta minus this, I have to move the 1 over, get that away. So tan squared theta equals secant squared theta minus 1. And then get the tangent and the secant on the same side. So tan squared theta minus secant squared theta, which is what we want in our problem, that is just equal to a -1. So that's its replacement. So on this, I can replace the top with all of that goes to a -1. And the bottom I have tangent of theta. So it's just, again, it's like the top. I have -1 times 1 over tangent theta. And 1 over tangent theta I can always simplify, so -1 cotangent theta or just negative cotangent theta. Either way is fine. Now, the next example here on number 3, this actually is much nicer than it looks. If you FOIL it out or distribute, whatever you want to call it, this is the exact same thing as I started doing on this one. You have the same trig functions, cotangent, cotangent, cosecant, cosecant, but one's plus and one's minus. So when you do this, it's cotangent squared x minus cosecant cotangent x plus cosecant cotangent, it doesn't matter which one's first and which one's second, and then minus cosecant squared x. Alright, when you do this, the middle terms will drop out. So I have cotangent squared x minus cosecant squared x. When you see them both squared, you should go to your yellow sheet. And this is very similar to the problem we just did above. I want cotangent minus cosecant, so I need to move the 1 over, so it's a -1. And I need to move the cosecant over that way, so ultimately I will equal a -1. If you need further explanation, just let me know and I'll help you work through it tomorrow. Alright, last one here. So, work through these two. So, distribute. 3 times 3 is 9. 3 times 3 sine x is plus 9 sine x minus 9 sine x minus 9 sine squared x. Middle terms cancel out again, so these are the same thing, 1 plus 1 minus, so it's just the first thing squared, which is 9, minus the second thing squared. Okay, GCF. Pull a 9 out. Hopefully that's looking familiar to you. It means you should go to the yellow sheet. This changes into just kidding, cosine squared x, and the 9's just there, so nothing more to do. Alright, so for finish up these notes for tomorrow, just work through, no, you don't actually have a book, it was just from an old textbook we had. Match these up, so match these on page 7. 25 through 30, match them up with which one on top. That's it. We'll see you tomorrow. Bye.